This is Algebra 2 with Trig, 8C.1a. We're going to learn about law of sines. Law of sines is a formula that we're going to use to solve triangles. These triangles do not have to be right triangles. They can be any type of triangle. Notice that when we have our angle ABC, side A is across from angle A. Side B is across from angle B. And side C is across from angle C. That's very important to recognize that relationship. So we'll come down to our first example. And we're going to solve triangle ABC. Notice that angle C is 100. So when I draw my sketch, I'm going to draw it with an obtuse angle to represent that 100. So that's going to be my angle C. I can put my acute angle anywhere I want to. I'll name it up here, 34. That'll be my B. And that means my final angle would have to be A. Side A is going to be across from that. Side B, which is a length of 8, is going to be across from angle B, and side C is going to be across from angle C. Now here's what you want to recognize. Here's what you want to pay attention to. Most important information of the whole lesson. Do you have two bits of information for the same letter?
Yes.
We have side B and we have angle B. That's the easiest way to know if you use law of sines. Can you use law of sines? Yes, you can use law of sines if you have two bits of information for the same letter. There's some comments in our notes here that say we can use law of sines anytime you have angle, angle, side, angle, or in a case we'll talk about in the future, SSA. We talked about this in geometry class that we could not prove triangles using SSA, but we'll discuss the situations. We'll try to discuss some of those at the end. In this situation, we have two angles and the side not included, the non-included side. So we're more like this. Again, I don't focus on the angle, side as much as I focus on two bits of information for the same letter. So because we have the B information, I need to use the fraction that has the B in it. So I'm using the B fraction, the B ratio. Now, which other fraction should I use? If I notice I have C, I don't know anything about A at this point, but I do know something about C. I'm missing one bit of information for C. So let's solve for side C. So I would suggest to start out your problem by writing out the proportion using letters. Then you can go ahead and plug in the 8, plug it into 34 for the sine of 34. We don't know side C, and we have sine of 100. Now, since we know why we're using it, we have two bits of information, and we're solving for an unknown. We've set it up. Now it's time to cross multiply. In this situation, we would only need to cross multiply in one direction, because we don't want to bring the sine of 34 up to the C and then just divide it again. We'll just leave it down in the denominator. So now we have 8 times the sine of 100 divided by the sine of 34. That comes out to be 1409. So next, we have to solve for something to do with A. But I don't have either A right now. So that's pretty difficult to solve for if I don't have either one of them, because I would have a ratio that's blank on top and on bottom. You have 2 unknowns. But notice that you have 2 angles given to you. If you have 2 angles given to you, you can always solve for the third angle, because you know that the measurement of angle A has to equal 180 minus the angles that you already know about. So angle A is going to be 46 degrees. Now what do we need to solve for? Side A. So of course we're going to use the fraction with the A's. And we can use either of the other 2 fractions, but I probably don't want to use it with the decimal. So let's go back and use with the information they gave us. So I'd suggest using B over the sine of B. So always start writing your proportion with the letters first. Then we can plug in. We don't have any information for side A, but angle A we decided was 46. Side B was 8. And angle B was 34. So the sine of 34. So we're using law of sines to solve for side A. We already have 2 sides. We can't use Pythagorean theorem in this case because this is not a right triangle. It's obviously an obtuse triangle. We don't have a 90-degree angle in here. So we have to continue using law of sines. So we're going to cross multiply and get 8 times the sine of 46 over the sine of 34. So 8 times the sine of 46. Very important that you are in degree mode. This will only be working out for you if you're in degree mode. So if you hit mode, you have to be in degree. And we're going to divide by the sine of 34. 10.29. Notice that the 2 smaller sides have to add up to be bigger than the longest side. And the largest angle is always across from the longest side. The middle angle is always across from the middle side. And the smallest angle is always across from the smallest side. So that's law of sines. Here's a situation where we have a 51-degree angle. We have a 44-degree angle. Together, those add up to over 90. So I know my missing angle is less than 90. So I have an acute triangle. You can name the vertices in any order you want. I'll put my 51 here and my B, so that'll be my 44. I don't know C at this point. Side A is across from angle A, side B is across from angle B, and side C, we know that one, and it's across from angle C. Notice here that we have two A's and the S in between. That would be angle side angle. So this time we're over here solving the triangle in a format for angle side angle. We can still use law of sines. That's what the notes show us. But I thought you could only use law of sines if you had two bits of information for the same letter. You have to set up your proportion. And you need two bits of information for the same letter. We don't have that. I've got angle A but not side A. I got angle B but not side B. I have side C but I don't know angle C. You can solve for the measurement of angle C by taking 180 minus your 51 minus your 44. That gives us 95. So angle C has to be 85. So now I have two bits of information for the same letter. So I'm going to use C over the sine of C. And I seem to be ready to solve for either missing side. It doesn't matter which one I solve for first. I'll solve for A first. So I always start with my proportion with letters. Side C is 11. Angle C is 85. Side A we don't know. Angle A is 51. So now we can cross multiply. We only have to do one direction because our variable we're solving for is already on top of the fraction. So we have 11 times the sine of 51 over the sine of 85. That's going to equal the value of A. So we have 11 times the sine of 51 divided by the sine of 85. And we get 8.58. Now we're looking for one more bit of information, and that's going to be side B. So we have to use B over sine of B. And I would suggest to use the whole numbers. So use C over the sine of C. So B over the sine of 44 equals 11 over the sine of 85. We plug in our numbers into our formula. We cross multiply one direction because our variable is already on top of the fraction. We use our calculator. All super zoomed in here even. Let's zoom out a teeny bit. We have 11 times the sine of 44 divided by the sine of 85. Remember, you've got to use your parentheses correctly. You've got to be sure you're in degree mode. And we get 7.67. So that's side B is 7.67. Notice that the two smaller sides add up to be bigger than the longest side. The largest angle is across from the longest side. The middle angle is across from the medium side. And the smallest angle is across from the shortest side. So moving on, let's try one. You can try this on your own. Pause the video, work through the problem, come back and we'll work you through it. So we have 94. We have C at 67. We don't know B yet. Side B is 25. That's going to be across from angle B. I'm going to be solving for side A. So we're looking for 2 bits of information. We don't have that. But we can get that by solving for that missing angle. So the measurement of angle B is going to be 180 minus everything else that we have here. So we take 180 and subtract 94 and subtract 67. We're going to get 19 degrees. So now we're going to solve for a side. We have to include the 2 bits of information that we have, so we have to use the fraction of B. And then you can solve for either of the other 2 sides that you want. I'm going to start alphabetical order and solve for side A. B is 25. The angle of B is 19. Side A is unknown, sine of 94. We cross multiply one direction. That's the value of A, and we type it into our calculator. So we've got 25 times the sine of 94 divided by the sine of 19, 76.60. Seems pretty big. But remember, our 25 was across from 19, the angle degree of 19, which is considerably small. To solve for an angle that is 94, and we're looking for the side opposite 94, it's going to be considerably larger, which here we are. All right, now we're looking for side C. We need to work with the B fraction. We don't have side C, but we have angle C. We've got side B, we actually know angle B, which is 19. You can only have one unknown in your proportion. So C equals 25 sine of 67 over the sine of 19. And we can type that in. and we get 70.68. That was side C. 70.68. A is 76.60. So when you solve a triangle, you have to find all the missing sides and all the missing angles. Now the last example down here is a tad bit different. Take a look at our information. We know that B is 104, so I made it an obtuse angle. Side B is across from that, which is 25. Notice we have two bits of information from the same letter, so we're going to use law of sines. Now I can put my A and my C. It really doesn't matter where I put them. I'll put my A in that vertex and my C in this vertex. Side C is going to be across from angle C. Side A is across from angle A. Now what are you going to do here? We have two bits of information for B. I don't have any information for A, and I can't even get angle A. I can't subtract from 180 because I don't know what I don't have two of the three angles, so that doesn't help me. But I have one of the C, so I can solve for angle C. So I need to use my C fraction, and of course I need to use my B fraction. C is 18 over the sine of C. B is 25 over the sine of 104. This is the first example where we're solving for an angle. So we're going to need to cross multiply in both directions. There would have been an option to have taken the reciprocal of both of the fractions, both the ratios in the proportion, and you would have put the sine of C on top. You're welcome to do that. But setting it up the way that we have, we bring the sine of C up with the 25. So now I'm going to divide by the 25, and that gets the sine of C by itself. So that's going to be 18 times the sine of 104 divided by 25. That gives us 0.6986. And at first, I don't feel that that's right because it's such a small value. But remember, this is not an angle. This is not a side. This is the sine of an angle. And you know sine has to always be less than 1. So now for us to find the value of measurement of angle C, we need to do sine inverse of 0.6986. We're going to do sine inverse of the sine of C, which is there. It's approximately. Now notice how I'm going to do this. I have to hit second sine to get my inverse. That's the -1. You use that to solve for an angle. And be sure to include the answer, the previous answer. Don't just type in 0.6 or 0.69. Be sure it's at least the 4 digits. Even better to be the ANS. And you get 44.32. $44.32. Now the last thing that we're solving for is the measurement of angle A. And A is going to be 180 minus 104 minus 44.32. So we have 180 minus 104 minus our previous answer, and that gives us 3168. So now we're ready to solve for side A. We need to solve for all the angles and all the sides. So of course, I'm going to use fraction A, and I'm going to use fraction B. A is what we're solving for. The sine of 31.68, we might need to use that rounded value. B is 25 over the sine of 104. We cross multiply in the one direction. Even if you don't have a calculator, you can at least get to this point. No calculator is not an excuse to not do the work. So we have 25 times the sine of 3168 divided by the sine of 104. We get 1353. Notice that your two smaller sides add up to be more than the longest side, and that the largest side is across from the largest angle, and so forth. This is on the flip side. So we're talking about the law of sines. This is for situations with side-side angle. We haven't been doing any of these problems yet, but we have different scenarios, and this is a flow chart that we'll pay some attention to that'll help us determine. I want to demonstrate what can happen. If we have an obtuse angle, all right, we have two things that can happen with an obtuse angle. If this angle here is obtuse, we'll call it angle A. We can pretend that this side might be (10). If this side is too short, and that too short is all going to be related to if it could come all the way down and touch this side. But if it's too short, it's never going to touch the side. If this side opposite is less than the 10, it's never going to touch this side. So if this was a 7, you're going to have no triangle. No triangle can be formed in a situation like that. And that's what we have here. In an obtuse triangle, you would have no triangle if angle A, or side A, is smaller than side B. The other situation that you have with an obtuse angle, if your angle here, angle A, is obtuse, this side is longer than our 10. Okay, let's call it 15. If it's considerably longer, then it's going to reach out, and that's the only way you can make a triangle out of it. Notice that we have an angle value, a side and a side, angle, side, side. It's an obtuse angle followed by two sides. Obtuse angle followed by two sides. If this opposite side is smaller than the adjacent side, then you have no triangle. If the opposite side is greater than the adjacent side, then you have one triangle. And that's what this says. If side A is greater than when you swing it and bring it down to touch, this is the only spot it can touch in. Now, what if angle A was acute? We could have an angle here. We'll call this a 55-degree angle. It seems a lot more than that. See if I can tighten that up a little bit for us. Okay, a 55-degree angle. And then we're going to extend this side, and we'll call it 10. Now, there is one situation that you could come down and hit a perfect right angle. And we can determine what that is by saying the sine of 55 equals this opposite side, we'll call it the height, over the hypotenuse. So that's 10 times the sine of 55. That would equal our height. So using a calculator, if we had 10 times the sine of 55, it would be 8.19. If this was exactly that value, we would have one triangle. This would open up. We were given an angle, a side, and a side. If it hit this perfectly, we would have one right triangle. But it would have to be exactly the sine of the angle times the adjacent side. If it's exactly that value, we have one right triangle. It is possible to have one right triangle. If you have your 55-degree angle and you extend your side out 10 and you are less than your 8.1, so let's call it 7, and you swing this around trying to touch the other side, it's never going to touch the other side. So you get no triangle. No triangle is formed. That's what this is saying. We had one triangle formed if it equaled the height. If it's too short, shorter than the height, it never touches. You get no triangle. And then the complicated one, if we have our 55-degree angle and we extend our side out 10 and we extend this side out more than our 8.1, okay, we'll call it 9. So we have angle side side. We can extend this out so it makes a triangle. And that's outstanding. We made a triangle. And we can solve for the missing bits of information. We have 2 bits from the same letter, and we can solve for our angle, and then we can subtract to get 180, and then we can solve for the missing side. But if this 9 can swing in here, it could also swing over here. Now we have two triangles, both with a 55-degree angle, both with a 10, and both with a 9. They're longer than the height, but they're shorter than the adjacent side. So you have two triangles that are formed. You have two sets of answers. This triangle in the middle would be isosceles, so these angles are the same. So inside the triangle that we're working with, this obtuse angle would be supplementary with the angle that we found on this end. So you subtract from 180 to get the obtuse angle, then you add them together and subtract from 180 to find the third angle, and you then solve for the missing side. You have two types of triangles to solve for this one. Possibly no triangles if it's too short, and then we have one exact triangle. The other situation you have with one exact triangle is if this is 10 and this side is more than 10, there's only one way you can make a triangle with that. You can't swing it under. Again, you get one triangle. So the time that it gets tricky and you have two triangles is if the side opposite is longer than the height but shorter than the side adjacent. Then it can fit in here in two different spots. But if you're longer than the side opposite, then you make only one triangle because it can't swing underneath. It's too long. It's 12. It's way past the 55. This just gives us a little breakdown of what this chart means up here. We're going to use this in the future.